right, so far we've dealt with factoring polynomials. We've done a lot of work with factoring polynomials, looked at multiple different methods and formulas, and even a general overall strategy. If given a polynomial, how would you factor it? What steps would you take? What should be your thought process? And now we're going to put all that to use in solving equations. Okay, so if we're just asked to factor a polynomial, you would just use those strategies and formulas and come up with the factors. But here we're going to actually go a step further and try to solve an equation using that information. Okay, so we'll call these polynomial equations. The first thing is there's an underlying principle here that I need to show you before we can really get into solving the equations, and that is something called the zero factor property. And it really is related to something that you've seen ever since basic arithmetic, ever since you learned basic principles of arithmetic. When you multiply by 0, the answer is always 0, right? Just kind of a general rule. But did you also know that the only way to get a product of 0 is to multiply by 0, right? So, in other words, you guys probably know that 0 times any number is 0, right? And any number times 0, because multiplication is commutative, you can switch the order. It doesn't matter whether the 0 comes first or last. You also probably know that 0 times itself is 0, right? So, so the question I just asked a moment ago is, so if 0 is the product, what are possible factors, right? So if you had two things multiplied together, spell it right, what are A and B? That's the question. If A times B is 0, what are A and B? Well, obviously, if one of them is 0, the answer is 0. And if both of them are 0, the answer is 0. The question is there anything else? Is there any combination where neither one is 0? Right? If you had like 2 times 5, right? Neither one is 0. Could you ever find two numbers who aren't 0, that aren't 0, and make them equal 0 when you multiply them? The answer is no. That's a zero factor property. Okay, the zero factor property basically says that if you have a product equal to 0, at least one of the individual factors must have been 0 to begin with. Has to be that way. Okay, so we would say if A times B is equal to 0, then either A equals 0, B equals 0, or both of them equal 0. Okay, it has to be that way. There's no other option. There's no non-zero option where both numbers are not 0 and the answer is still 0. You have to have one of the two 0. Okay, that helps. That's useful for what we're going to do next. Because when you're looking at two things that are multiplied together, we call them factors. Well, of course, we just learned how to factor polynomials. So if you had two polynomials multiplied together, let's say you had, let's take something simple, x times x plus 7, and set it equal to 0. Well, here I have two things multiplied together that equals 0. Right? It's a product. If there's one factor, there's the other factor. So in some sense, you kind of have an A and a B, right? You have two things multiplied together, right? And those kind of small. You have two things multiplied together here, an A and a B. They're two different polynomials. But if their product is 0, if they equal 0, then we know with certainty, because of this property, that at least one of those two, maybe both, are equal to 0. Pretty much in all of our situations, or most of them, we're going to take one or the other. We don't need them both at the same time because there's no x value that's going to solve both of these factors and make them both 0. Okay, but there are x values that will make one 0 or the other. So all we have to do to figure that out, if we know that their product is 0, then we know that either the first one is 0 or the second one is 0, right? Either the first one is 0 or the second one is 0. Must be the case. And so by starting out with two factors equaling 0, we can essentially set each of those equal to 0 individually and end up with two equations that are much simpler to work through. Okay, x equals 0 is already solved for. 0 is one of the solutions, but also if I solve x plus 7 equals 0, I get negative 7. I have a second solution, x equals negative 7. And so these two numbers would be included in the solution set. Remember, we're going to be dealing with solution sets when we're solving equations. Okay, so equations require a solution set. And here the solution set contains 0, and it also contains negative 7. Here's the first time, the first instance where we're going to see solution sets that contain more than one number. We did see solution sets for systems of equations that contained, potentially an infinite number of solutions, but they were all ordered pairs. Here we're just looking at individual numbers, and now we're going to start seeing where you could have 2 or 3 or 4 solutions depending upon how complicated the polynomial is. Okay, so this is kind of a basic example. And if you were to plug this 0 or this negative 7 back into the original equation, you'll get a 0, you'll get an output of 0 on each side, right? So if I plugged in 0, I get 0 times 0 plus 7 is 7, so 0 times 7 is 0, that works. If I plug in negative 7, then I get negative 7 here and negative 7 here. This negative 7, this would simplify to 0. Negative 7 times 0 equals 0, and so that works, okay? Where this becomes really interesting is where we apply the factoring idea to the equations. So I gave you this problem already in factored form, but you may be given problems that are not in factored form. So you have to factor them first and then set the factors equal to 0, okay? So there's really a multiple step process to this. The first thing is you can't even use the zero factor property unless you have a 0 on one side. So the very first thing you have to do when given a polynomial equation is to get a 0 on one of the sides. I tend to try to get it on the right, it just makes more sense in my brain, but equations can be flipped, so it doesn't matter if the 0 is on the left or the right. So the first thing is to get 0 on one side. That's the first thing you must do. The second thing you must do is to factor the remaining polynomial. Okay, it'll be on the other side of the equation. Now the one I gave you, both those first two steps are already done, right? There's already a 0 on one side and it's already factored. It could be the case that you don't have to do some of these steps, but as a general principle, these are possible steps. You may just be able to skip them depending upon what's given to you. So once you have it factored, then step 3 is to set each factor equal to 0. Okay, set each factor equal to 0. That's what we did here when I took the first one and the second one, set them each equal to 0. Then you solve the resulting equations. Okay, solve the resulting equations. And there will be more than one typically, right? And then of course the fifth step is just showing our solution set. Okay, so put your answer in a solution set. Of course, it's good to check your answers too if you can do that either in mentally in your head, or maybe on a calculator, or even work it out on paper, either way, but just to check and make sure that what you did was correct. So kind of like I did here with the 0 and the -7, plugging them back in and making sure it zeroes out on both sides. So let's go ahead, I'll give you a couple more complicated examples, and we'll see how we kind of use these 5 steps to work through that. Eventually, I'm hoping you don't need the 5 steps. Once you get a few examples in, you'll just kind of go to you'll know exactly how to start these off. But just know these are the 5 sort of key things you want to look for. Let's do something like x squared minus 8x minus 20 equals 0. So here's one where we have to do some factoring. The lead coefficient is 1, and so I can just go straight to my shortcut. It's like the modified AC method, but it's a simpler, quicker one, where I just go to a set of parentheses. And of course, I've got a 0 on one side, so I'm skipping that and going to the factor in the remaining polynomial. So I'm factoring this. I've got an x on each side or each of the first terms. The constant needs to be the pair of numbers that whose product is -20, but add up to -18. And so if I look at the factors of -20 for a moment, the bigger one being negative because they have to sum to a negative, so it'd be 1 and -20, 2 and -10, 4 and -5. Well, the 2 -10 combo is the one I want to get -8. So I'm going to have a +2, a -10. Now, of course, I'm not done. If I was trying to factor a polynomial and I didn't have the equation in there, the equal sign, then I would be done here. However, in this case, I have the equal sign, so I'm actually looking for the values of x that solve the original equation. So that's where the rest of this comes in, setting each factor equal to 0. So I have 2 factors. Actually, this whole thing should be equal to 0. I didn't give myself enough space there. Okay, don't forget to equal 0. Then you set each factor equal to 0. Solve the resulting equations. So subtract 2, you get a -2 here, add 10, and you get 10. So -2 and 10 are the actual 2 solutions, and I'm going to go ahead and put them in solution set, -2, 10. Okay. Now, if I were to plug -2 and 10 individually into this equation, the left side is going to zero out. Just notice it for a second. Let's try the 10. 10 squared is 100. 8 times 10 is 80. 10 minus 80 minus 20 is 0. Okay. Did I say 10? I meant 100 minus 80 minus 20. I'm not sure what I just said there. If I plug in the -2, -2 squared is 4. -2 times -8 is +16. So if I did 4 and 16 makes 20, minus 20 makes 0. So it does work out in both cases. All right. Okay, so that gives us all of our steps. We were able to skip the first one again because it already had 0 by itself.